Kia ora, Year 12 and 13. This is a really nice integration by substitution question from the May-June A-Level papers, paper 32, question 8. So I want you to have a look at the problem first and then work through it as I go. We're given a substitution to use here, and it's a really good substitution. It makes this problem very, very doable. Just remember, you've got to switch everything over to get it in terms of u. Okay, so when I look at this integral, the first thing that I notice is that sine 2x in the numerator. Before I do anything with the substitution, I'm going to deal with that just in my setup. So I've got 2 sine x cos x dx here, and in the denominator I've got root 1 minus sine x. And I'm going to go through and slowly replace everything with u. So this bit here is obvious, but the next step is probably to differentiate du by dx, and that will give me negative cos of x. You can see that du is equal to negative cos x dx just by rearranging this and separating the variables. Now I want to have cos x in here, so negative du is going to replace the cos x dx, and we can just highlight as we go what we've dealt with. Now what about that sine x? Well, u is equal to 1 minus sine x, so sine of x is equal to 1 minus u, and that gets that done. The last thing we need to switch out are my limits of integration. So do a little table. We've got x here, u is equal to 1 minus sine x. X is 3 pi on 2, gives us 1 minus sine of 3 pi on 2. That's not sine, that's my cosine graph. Really, clearly haven't had enough coffee yet this morning. There's 3 pi on 2, so it's 1 minus negative 1. 1 minus sine of pi is going to give me 1 minus 0. So the top limit is now 2 and the bottom limit is now 1. Okay, so pause the video here and do your go at rewriting that integral, all in terms of u. So this is what we should get. We should get the integral is equal to the integral between 2 and 1 of negative 2 times 1 minus u du divided by the square root of u. And you can see already that that is massively easier than the thing that we started with. All right, so I'm going to now rewrite that with fractional powers, and I get negative 2u to the negative 1/2 plus 2u to the power of 1/2 du. And it would make sense to pull that negative 2. I should have kept that negative 2 out the front to start with. So integrating now, let's just do that in here. So I've got negative 2 times the integral of u to the negative 1/2 plus, minus u to the 1/2 du. Okay, so it usually is easier to just whoosh that constant out the front. What do we do here? Well, the u to the 1/2, negative 1/2 will become u to the power of 1/2 times 2, and then u to the power of 3 over 2 is going to be minus 2/3 u to the 3 over 2. Now don't stop watching because we need to get this into a specific form. So there's a little bit of surd manipulation stuff to go. So I'll do that now. We're going to have negative 2 times, in first bracket, 2 root 2 minus 2/3. Now u to the power of 3 over 2 is going to be, I'm going to write that as root 8 for now. Okay, we'll come back and clean this all up. Minus 2 times 1 minus 2/3 times 1. We know that root 8 is 2 root 2. So that's the next cleanup step that I'm going to do. I have 2 root 2 minus 2/3 of 2 root 2 minus 2 plus 2/3. That was actually really silly. 2 minus 2/3. We might as well clean that up now. So 2 minus 2/3 is simply 4/3. Right, so what have we got? We've got negative 2 times 1 lot of 2 root 2 minus 2/3 of it. So 1/3 of 2 root 2 minus 4/3, which gives me negative 4/3 root 2 plus 8/3 So writing that in the form that they wanted, that would be fine, I'm sure. But 8/3 minus 4/3 root 2. So there you go. I think it's a really nice example of substitution. I think it's a great question if you're watching and you're not doing A level. For level 3, there's nothing in there that is too difficult for a level 3 problem. Although it is good to have done trig so that you spot that double angle straight away. Thanks for watching. Keep on sending in your questions and I'll be back into doing videos from now on.